Our next topic is the H parameter. This is the hybrid parameter. The hybrid parameter, the equation of your voltage and current. This is the describe here the two port circuit. Here is the two port means this one of the circuit inside this box, and the terminal is one of the terminal is this one. This is the one of the terminal. This one of the second one of the terminal. That's why we call a two-port network. In the two-port network, we describe the different types of parameters such like your Z parameter, Y parameter, ABCD parameter, and similar way this is your H parameter. The relation of your H parameter with your voltage and current, this is described by your matrix form. This is a matrix form, means this V1 and I2 is equal to your H parameter of matrix is equal to I1 and V2. This is the relation of your H parameter, that is the two port network. Now this equation, now this matrix is now in the form of equation. Now this is come in the form of equation. Now we describe the this H1, what is the H11, H12 and H21 and H22. Now this parameter, this four parameter we obtain by the ratio, and some value is put short circuit or open circuit. Suppose we find out the H11, then we put V2 is equal to short circuit or V2 is equal to 0 value. Then this term is equal to 0. Then the ratio of V1 and I1 represent your H11. Here is written here. Means H1 is the ratio of V1 and I1 when V2 is equal to 0. This is called as a input impedance. This is called a input impedance. Also this represented when we go to your transistor configurations. This is represented here H suffix I, HI in the form of. The notation is just changed here HI. The H parameter, the describe here the common emitter transistor. The H parameter describe the here the common emitter transistor. This H parameter we already study in the such like subject your network theory NFTL. This parameter is described. That describe the there is the in this form. This is the H11, V1 and I2, V2 is equal to 0, and this is called input impedance. Now in terms of transistor we use notation such like H and suffix I, HI. And next to move S21, this is the ratio of I2 and I1 when V2 is equal to 0. Now put the value of V2 is equal to 0 in this form, V2 is equal to 0, then we obtain the H12, this H12 parameter. This is called as a forward current ratio. This is forward current ratio, or also be called forward current gain. Two form we say that is the forward current ratio we can say, or we can say forward current gain. This parameter. This also in terms of when we describe in the common emitter transistor or any transistor we use a H suffix F, means HF notation we use here. Similar way H12 is the ratio upon V1 and V2 when I1 is equal to 0. Here put the in equation, then we obtain this relation. This is called a reverse voltage ratio. This ratio is called a reverse voltage ratio. Notation here is H and R. And similar way H22, this is called output admittance. The notation used here H naught. Yeah, or we use HO. Now the H parameter what we study in the network theory or NFTL, then this the circuit is obtained, this equivalent circuit of H parameter. How this is obtained? Now to observe this equation, this of the equation of one of the equation is usually the second of equation. By using these two equation we can draw equivalent circuit of this equation. How can we can draw? To observe this one, now font is now small here. Okay, also decreases. To observe this one, first we set there. Okay. To observe this one, first of equation, this is equation V1 is equal to H11 I1 plus H12 V2. Now this equation draw in the equivalent form. This is the V1. Here is the V1 is equal to H11 and I1, means product of H11 and I1. Now here to observe this one, H11 this current, this is the product now obtained here, means V1 is equal to H11 I1 multiply this N1 H11. Next, this is the H12 V2, means V2 is depend, this is the input side, this is the output side, means V2 is the output side and H12 in your input side depend, means this is a dependent voltage source as created here, means this term is create the voltage dependent source, means this equation is obtained here by using this equivalent circuit. We can draw here. Similar way, the second term, the current I2 is equal to, similar I2 current is equal to S21 I1. Here the current S21 I1 and S22 V2. Now overall conclusion of this one, by using this equation we can draw this equivalent circuit of your H parameter. This is your equivalent circuit of your H parameter. Now in our topic, to draw H parameter of your transistor. Now we consider the transistor common emitter transistor to draw H parameter. Now we can draw the circuit of your common emitter. Here this is your common emitter. Here we cannot draw a voltage divider. Sorry, here we cannot draw your the different types of, we studied different types of your biasing circuit, such as fixed bias circuits, voltage divider bias circuit. Here is the, we cannot draw voltage divider bias circuit. Here is the common emitter circuit because emitter is grounded here. Now this circuit to draw a H parameter. Now to focus upon this one, to draw this common emitter circuit H parameter. Now to observe this one, this is to categorize in the two-port form. Two-port means this is the one of the input port, this is your output port, means the H parameter is the two-port network. This is your input port, this is the output port. This is the current V1 and I1, this is the V2 and R2, the output side. Similar way in this circuit, this current VBE and the current your IB. This is the input side, then your output is the VCE and your current IC. Similar way the equation will be create. Similar way one of the relation, similar way this one of the relation, then H parameter you obtain. Now this VBE and IB we put here, VBE and second is the IC. IC, how we can put the IC here, because V1 is the this input side and I2 is the output side. Similar way VB is your input side and output is the IC, that's why we use here. Similar way the current, you observe this one by equation, current is I1, input side of I1 and output side of your V2. Similar way input side of I1 means the input side of I1 is the IB and output side of voltage is the VC. Similar way VC. And just notation put here, this is your H11, this is the H12, this is the S21, this is the S22. How this one? Because we observe this one H1 is equal to this one HIE. Similar way put here HI. Therefore we use here suffix IE. E is here represent emitter. Here also we use E. This also parameter use E. Overall H11 in the place of HIE we use a suffix E and HFE and similar way here. Means overall we replace the all the parameter which is be observed here with using this notation, this for notation, with use a suffix e, and the obtain here, this is the h parameter of your common emitter circuit. Now this matrix form also expand in the your equation form. Now this equation form or matrix form be expand here. Now to draw the equivalent circuit means in this form we can draw, just replace here, means V1 is equal to here VBE, means this is your input side VBE, this is your V1. Now next is your I1, here is the I1 is the IB. Just replace all the values with respect to your whatever we study your two port network. To now observe this one, this VBE is your input and current is the IB. Similar way we use here H11 H11, we in the place of H11 we use here HIE. Similar ways we put H12 place of here HRE. Means overall conclusion of this one, whatever the value of this one be replaced by these notations. Now this is now form a h parameter of your common emitter transistor. Okay.